For the acceleration problems, we're going to treat them the same as the constant motion problems we did in the sense of the process. The equation is going to change because now you got a change in speed. So we're no longer going to do just the v equals d over t. We're going to add in some equations, which we discussed with the notes. But the the gist, you still do the same process. We try to picture it. We draw a picture if we need to. This one, average race car goes 93.9 meters per second. How far in miles is it going to take to stop? So if it is going 93.9, how far would it go if it just slammed on the brakes? And then it tells you the acceleration of the brakes. So acceleration is the change in speed of the brakes. It's 8 meters per second squared. So that's our new thing. That's the acceleration. It's 8 meters per second squared. We're looking for how far we're going to go in miles, so we're looking for D. Now the 93.9, we definitely know that as a velocity because of the meters per second. The question is it initial or final? And then that you get from the problem. We're going 93.9 meters per second because it wants to know how far we're going to go when we stop. So our initial is 93.9 and our final is 0 meters per second. Now, before we go on from the variables, check the units. Meters, 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 seconds, seconds, seconds. We do not have to convert anything. Everything's the same. Units are good to go. Now we want to pick the equation. What equation should we use? If you're looking at your equation sheet, there are 3 new equations on the right. And the easiest way to do this is to ask yourself what's missing. There are 5 possible things they could give us. Acceleration is one of them, distance is one of them, initial speed, final speed, and time is the other one. So in this problem, we're missing t. It never mentions anything about time. You got 2 options. You could use the information given and find it, calculate it, but that's extra time. You have to do another equation. You have to set up a whole nother problem. Your easiest solution is to use one that doesn't have time. Use an equation that doesn't have time in it. So we are going to pick, if you're looking at the equations, the only one that doesn't have time in it is Vf squared equals Vi squared plus 2AD. Again, don't rearrange the equation. Don't worry about any algebra math stuff right now. Just plug in the numbers that you have from above. Vf is 0. Vi was 93.9. Squared plus 2 times, now the acceleration was 8. And you're going to solve for D. Now, to solve this problem, before we solve this problem, we got to stop and think for a second. We made 93.9 positive, which means you were going in the positive direction. So we made 93.9 a positive. So the only way you can slow down is if the acceleration's negative. So this 8 is actually negative. So when we go to add, we can add this term to the other side. We'll add a positive. So our distance is going to come out positive because that's the direction we were going. If you leave the 8 negative, then you'd get a positive displacement. You get a negative displacement, which would it's not wrong. Just you said you were going the other way. So then your 93.9 should be negative to give you a reference to that. It doesn't really matter for this one, but you need to watch out if the acceleration is negative or positive because it could change the answer. So let's go ahead and solve this now. I'm just going to take this 2 times 8 is 16, so it's a negative 16d. So you got a negative 16d. I'm going to add that to both sides. Whoops, that's a d. So we got 16D equals 93.9 squared. Then just divide both sides by 16. And that's your answer. So D is going to equal, it's going to give us 551 meters. But it wanted it in miles, so you got to take a second and do a little conversion. Here, we'll do that. I'll do it in blue. You got, so it's a train track situation. You got 551 meters. We can look up that there's 1609 meters in a mile. So if we do 551 divided by 1609, that'll be our answer. So our final answer is going to be D equals 0.34 miles. So going around 210 miles per hour, slamming on your brakes with an acceleration of 8 meters per second squared, you're going to go about 3/10 of a mile before you actually come to a stop.